Hi, my name is Catherin Breslin. I founded a company called Kingfisher Labs, a consultancy which helps companies who are building voice and language technology. And I love a cup of coffee, and my favorite is a black Americano.
I've got the best joke for you, man. I don't know if you're going to like it or laugh that much, but have you been to Greece?
No, I don't think so.
All right, so no shade to any of my Greek brethren out there. I'm going to tell you the 5 things that you're going to find anywhere you go in Greece, whatever island you go to, the mainland, all that good stuff, all right? So first one, you're going to find the best tomatoes that you will ever eat in your life, like the juiciest, reddest tomatoes that you will ever eat, and they're delicious. The second one, incredibly blue water, all shades of blue, turquoise, any kind of different shade of blue you can imagine. They have the water that's that color. It's clear. It's incredible. Then you've got, this is where it starts to get controversial. You've got half-built buildings. So concrete structures that have just been abandoned and people don't care about trying to finish building them or knocking them down. Anywhere you go in Greece, you're going to find that. And the fifth one is going to be someone from the UK that does not know how to use sunscreen.
Yeah, definitely. No, I think I know that person.
So that is I just got back from Greece and I was thinking about that because no matter where I've been in Greece, I see those 5 things. And anyway, we're not here to talk about that. Today, we were talking with Catherin and we were talking all about like speech recognition and machine learning with speech. What are your top takeaways from this?
Yeah, for me, it's a world I don't know very well and I've kind of avoided. It's like almost a completely different flavor of data science. So it's interesting to hear like right from someone that's done it at like Ph.D. level and gone into work at some of the biggest organizations in the world doing it, massive applications. So that's quite cool. I think getting under some of those suspicions about how these things are pieced together was quite interesting. So, like the fact that something like Alexa is like lots of different models back to back, and you just to fathom the complexity of that and the engineering in place, that's really quite cool, I think.
Yeah, one thing that I liked that she mentioned was how back in the day when she started on all this, how it was very much its own thing, and a lot of the tools you could not use. If you were doing stuff in other areas of machine learning, it wouldn't cross over to this type of machine learning. But now, with the advancements and just how, in her eyes, what it seemed like is that they were coming together very much so. And so you can use a lot of the same packages, you can use a lot of the same tooling. And that seemed really nice because I always am kind of dunking on how there's never going to be this machine learning stack, like the modern ML stack. And that I think is because there are so many different use cases that you have and so many things that you're optimizing for, so many different kinds of SLAs that you're looking for, all that good stuff. And with this, it almost was like a little bit of a pattern interrupt because she was talking about how different it is from when she started till now on the tooling, and it feels like the tooling is starting to become more friendly to this type of machine learning. So let me just give a quick bio on who Catherin is, and then we can jump into this full podcast with her. So Catherin is a machine learning scientist, and she founded Kingfisher Labs, which I believe she just mentioned to us, and how she likes to take her coffee. She did her doctorate working on automatic speech recognition at Cambridge, and then she has extensive experience working in automatic speech recognition, natural language understanding, and human-computer dialogue systems. And she worked at places like Toshiba Research, and then also Amazon, where she was one of the teams that launched Alexa, which is awesome stuff. So we dig into that. You can bet that we are talking a ton about what the experience at Amazon was like when they launched Alexa and how that matured over time. And we might as well just get into it, I think. Last but not least, if you have not subscribed to our newsletter, that is killing it right now. We've got some amazing newsletter writers. And so if you want to stay up to date on all of the cool stuff that's happening in the MLOps ecosystem, the MLOps universe, check out our newsletter. We've got 3 different ones, a weekly one that rounds up all of the stuff that we're doing as a community, a monthly one that gives background on and a little bit more thoughts, deep thought, and shows the best stuff that has come out in the broader MLOps ecosystem. And then a third one that is just all about the best threads that we've had in Slack. So jump on that. I'll leave a link to the description below. And without further ado, let's talk with Catherin. All right, so Catherin, welcome to the MLOps Community Podcast. This is very exciting. I know that we were just talking before I hit record about how you don't necessarily get to talk about all the cool MLOps stuff you've done. You mainly get asked about all of the research stuff. Today's going to be totally different. We're going to do something that is a little bit atypical. And before we get into that, I think it's probably cool just to hear a little bit about your background. Like, tell us, where'd you grow up?
Hey, well, thanks very much for inviting me on. My background is, I guess, very not hugely exciting. I have lived in the UK all my life. I know this is a very international field, and so lots of people have very exciting backgrounds. Mine is a lot plainer. So I've lived and worked in the UK since I was as young. I grew up partly in the south of the country, partly up in Yorkshire. Don't have a Yorkshire accent anymore, but I lost that when I moved down south again. But I've always been interested in maths and computers, physics, and all of those subjects all the way through school. I went to university to study engineering, and I ended up studying engineering and computer science as joint honours, which proved to be a really great introduction and a really great foundation for machine learning, which is, as you know, a combination of sort of engineering and maths and computer science. So this was how I started on the path to machine learning. That was quite a while back now, so machine learning wasn't as popular as it is today. But I still thought it was a really interesting field, and I was specifically interested in some of the things that, people can do, but computers couldn't. And I was curious about how can you get computers to do some of these things, like understand speech, things that children can do with ease, but we couldn't get computers to do with any accuracy. So I decided to go from there and study this subject more, and I ended up doing a PhD in automatic speech recognition here at Cambridge, which is where I still am.
And so what was the idea of this, or how did it go from doing this PhD to then starting to get more and more in depth into speech technology? Did you realize right away that, wow, I can now start talking to computers, or what did that trajectory look like?
I think, my PhD was about trying to improve speech recognition technology and how to make it better. So I studied that for a few years, and then I just stayed in the field. It was really interesting, and it combined a lot of interesting aspects, a lot of signal processing at the time, a lot of maths, a lot of computers, programming, all of that stuff mixed together. So I think it was a really interesting and challenging field. And I could see that although we weren't there at the time, and we're a lot better now in terms of speech recognition performance, I could see that this is technology that really could actually help people if we could get it to work. And so I could see that it also, as well as combining these challenges of the subjects I loved, it was something that had a real practical applications that I could see coming along. So that was really what drove me into carrying on in the field. And from there, I've spent my career in different aspects of sort of voice and language technology.
So one thing that always interests me about this space is it's not one I've really worked with much, but I imagine a lot of the technologies and tools and things that are used are very different to the kind of standard SQL database pipelines, like all that stuff. So yeah, could you just elaborate a little bit on kind of challenges around technologies and toolings that maybe some people aren't familiar with?
Yeah, I think that the tooling has evolved an awful lot over the past decade or two that I've been in the field. There is, in the same way that a lot of machine learning has become more accessible to people, there's been a lot more tools and libraries available. I think the same is true in the speech world. But you're right that a lot of the tools that I started using when I was earlier in my career were sort of hand built and custom made for the field because we were dealing with large audio files, similar to how maybe computer vision has the same challenges with large video and image files. So large audio files had challenges in storing them and accessing them and sharing them around. A lot of those are eased now because we have a lot more tools for dealing with these large files, and sort of the ways that we know to deal with them are in place now. But these have evolved over the time, and I think there's been over the past 5 years, perhaps, more of a standardization across more machine learning fields where a lot of the same tools and techniques are coming together now. So whereas computer vision and voice technology were disparate fields 10 years ago, a lot of the tooling, and that's driven a lot by the fact that the models underneath the hood are becoming similar. The sort of ways that they're used are becoming similar. They're being integrated together in new and interesting ways. And so the knowledge is being shared a lot more between the different fields, and there's been a much more of a alignment between the different machine learning fields.
Is that is like a similar trend reflected in the skills then as well? Because I imagine like you can't go out and get a generic data scientist again, because I don't think many people have worked with voice data and audio processing and things like that. So how do you find the kind of, is there a skills barrier? Is it easy to pick up, or do you look for a certain flavour of person when you go out recruiting for kind of these kind of data scientists?
Yeah, I think it's really important to have some sort of grounding in signal processing or language or engineering maths or something like that, which is a little bit more in depth than you might find in other places. Um, speech has a lot of quirks and a lot of lessons that you learn through your career, I guess, about how speech works and some of the challenges and the things involved in it. And so just knowing a lot of those things as you is a good foundation to be able to work from. Um, so I think it is opening up in the way that other machine learning fields are opening up, because the tools are getting more advanced and more standardized and easier to use, and they're developing nicer ways for people to interact with them. But fundamentally, I think you do need somebody who, in order to build sort of speech recognition systems, you do need some specialist knowledge about how speech works and how to put the system together to get the best out of it.
And when you look at the trajectory of when you started until now and everything that has happened and the ease and the developer experience, really, that change that has happened, and then you look at where we are now, where are some developer experience hiccups that you still feel like are there and you wish wouldn't be?
I think there is a small number of toolkits around for working with speech data. You've got the general ones like TensorFlow and PyTorch, where you can build up speech models in those, but there are a handful of sort of custom speech recognition toolkits, some of which have quite a long history, so they're quite old. And that means that people have built up a lot of knowledge about how to use them, and sometimes they're not as well documented as they might be, or you need a real expert to come and use them. So I think one of the challenges that people have, I see companies who would like to work on this technology, and they find these toolkits and they really struggle to work with them. So I think that is one of the hiccups. Although in general the field is moving towards a better developer experience, I think there's still a little bit of a way to go there. And this is work that is happening. I think people are taking these toolkits and working on them to bring them and make them more accessible to people. But still, at the moment, I feel like they do need some specialist expertise to be able to use them. That's one of the bigger hiccups I see. But then on the other hand, there is a lot of sort of practices and things that come from outside of this voice field that we've brought into the voice technology, which I think has made it easier. So there are, a lot of general purpose frameworks for building up models and running jobs on a distributed cluster. And those sorts of frameworks can be really just brought into the speech field and adopted. So having these combined with some of the toolkits that we use can lower the barrier.
So just the way you're talking there made me think, so say I'm a data scientist and I'm working for like an organization that's got the budget with maybe a team of us, and the next big thing that we've decided the value lies in like speech processing, right? We want to tackle that for our use case. Maybe it's localization, maybe it's a default dialect or something, I don't know. But where do we start? Like, what's your advice to that team and that person that goes, right, this is a whole new world. What do I do first and where do I go?
So there are a few levels of software that you can use. So I was just talking right now about the toolkits for building speech recognition, which is like getting right into the weeds, into the details and building your own system. But on the other end of the spectrum, there are services out there, cloud services, which do speech recognition for you. You can just stream your audio up, get the results back. Those are often the best place to start because they have great systems. They're actually really good accuracy for the general use case. They're easy to use. They're relatively low cost to try out a few things. So until you've actually sort of spent some time proving out your product and being sure that it's the right thing for you, these are a great place to start. So the big tech companies have these. There are a few other companies as well that have their own speech recognition services that you can use. So that's where I would usually advise people to start, is use what's there, what's relatively cheap and easy. And then you can prove your product without having to worry about the technology, because building that voice technology yourself in-house is an expensive undertaking and not one to go into if you're not really confident about the value it's going to bring.
I love that. Prove out the use case before you overcomplicate things.
Exactly.
So you went on to work at Toshiba Research, if I can pronounce it correctly. And can you give us a bit of the story around how that happened?
So Toshiba Research is also here in Cambridge, which is where I studied my PhD. They actually helped fund some of my PhD, and there are really close links between Toshiba and the engineering department here in Cambridge. And so that was a relatively easy transition. I knew that they were looking for people, and just as I was finishing my PhD, which was lucky for me because that was like 2007, when there was this global financial crash and a lot of people stopped hiring. So it was all of a sudden, machine learning jobs weren't that common at the time, and they were even less common in 2007. So I was really lucky to be able to move into Toshiba and carry on working there.
Nice. So then what I'm really interested in is some of the challenges that you faced while you were working there, and going from that and working in a research lab and the transition into working in the industry.
So I think there are some real differences between industry and academia that take some getting used to if you move between them. But one thing I would say is there are some research labs that are closer to academia and some which are further away from academia. Toshiba was a nice place to start because it was much closer to academia than some of the other places I've worked. Some of the places I worked later in my career have been even further away from that research world. But there are some real big differences, I think, when you move into industry. So if you're in academia and you're researching a topic, your job is to figure out how to model something better, how to come up with those machine learning models that do better on the task that you're looking for. Often you have the data, you have a data set ready prepared, or you might have to go and collect a data set, but you're building up a sort of static data set and you're trying to see how you can get the best performance on a particular task. And that's what a lot of academic research does. And that sort of proves out, what models we can use and how we can use them. And you take them into industry. The job is slightly different because you don't necessarily have the data there ready and cleaned up for you to use. You have to figure out what's the best data source and how you're going to collect it and what cleaning up it needs and things like that. You have to focus a little bit on the building the models which are going to get out into production. How can you make things better for your users? How can you look after the models that you've put out into production? Because you can't just put them out into production and forget about them. They have problems and bugs and go wrong sometimes. So there's a different mindset, I think, in thinking about how you can take machine learning and apply it to a business problem as opposed to an academic problem. I think that's a real transition which is tough to make in the first years after you leave academia.
Something you said there that kind of, I want to get onto the Amazon stuff, but just that bit around those bugs and like taking care of models in production. What does that look like for speech data? Like how do you unit test that kind of stuff?
So you obviously you can unit test the bits of your code if you know what the code is. But one of the difficulties of a machine learning model in production is that you don't know how it's going to behave. So it depends on the data that you've got. So you can only really accurately test your models. So you take a big data set and you see what the error rate is on your data set before you push something out, and has it improved from the previous iteration of the model. So you have to look at adding in sort of accuracy testing as well as unit testing and integration testing and all of that other kind of lovely stuff as well.
Yeah, okay. No, that makes sense. And so, yeah, I hinted at there. One of I suppose, the most commonly known speech recognition tools that people use day to day is Alexa, right? And so you were involved with that. What was and just linking back to the difference between like industry and academia, was that another step down the chain towards like production kind of powerhouse, like getting models out the door? Or was that still very researchy? What was the culture like there, and how did that go?
It was, another step away from sort of the very research focused. I joined Amazon just before Alexa was launched. I was in a lucky position to be able to see it launch and to see how it became mature. So that was quite a journey, figuring out what we needed to do to take this machine learning product and really make it robust and production worthy. Because this is something that there are a handful of machine learning models in production in the world, but at that time, but not a lot. And so we didn't really have, best practices to lean on. We didn't really know how to do it. So we were sort of inventing some of the stuff as we went along. So it was a real challenge to see how you could take this great idea, this machine learning. It was a sort of a pipeline of different machine learning models that strung together to make Alexa, and how to look after those and how to improve them, how to debug them, how to maintain them, and how to make them better over time.
Do you have any entertaining like war stories or horror stories from that time that you're allowed to share? Or?
None that I'm allowed to share, unfortunately.
Yeah, I bet there's some good ones that you can tell us offline. But the thing that I'm wondering about is when you were looking at this, because the launch of Alexa, and I'm just remembering like the launch of Siri and how bad it was when it was launched, and because we have such a high bar for what we expect from the machine to be able to do. And when you use a computer, specifically, like let's just take a calculator, for example, there's no way that you're going to think like the answer that this calculator is giving me could be wrong, or it might not have understood what I typed in, because it's a human error. If it gives me the wrong answer, it's because I did something wrong, not because of the computer. And then all of a sudden you shift that to something like Alexa, and it doesn't understand the way that I'm saying something, or it doesn't even hear me when I say, "Hey, Alexa." There's so many things that can go wrong, right? And so you saw, and you were on the team having to change the maturity of Alexa, or just incrementally make it better and better. And you talk about the fact that you needed to get it more mature. What did that process look like? Like, how did you evolve it?
So Alexa launched in 2014. It was just a few years after Siri had launched. And like you say, Alexa was different because it was a standalone device that had no screen either. So we had to be very thoughtful about the answers that Alexa would give, because there was no screen to back up what you were saying, to give a link to the web, or to click here for additional information or anything like that. So people do tend to trust a system that talks to them. We're very trusting of things that look human or sound human. So there's those factors to take into account when we're thinking about this. But when Alexa launched, you possibly don't remember that far back, but it launched in the US, and it had a handful of features, but nowhere near the feature set that it had now. So it started with some very headline features like playing music, asking the time, setting timers, various things like that. And new features were added over time. It didn't even launch with shopping on voice shopping, which is obviously, you'd imagine that Amazon being a retailer first and foremost, that would be a prime use case for them. But no, shopping wasn't even there in the beginning. So it was taken from a system which had just a few features, and it was a beta release with just a limited invitation release in the beginning to sort of trial out. It turned into a big success. I think it was there was nothing like it on the market, so it was unsure how it would be received. And I think it's really changed the way that people interact with voice technology now, and people have it in their minds, but at the time it was brand new. So over time, we took it from a system which had a few features to add more features, added more languages. So it came to Britain in Germany a year after, and that spread to other countries later, and onto other devices as well. So one of the things I worked on was how do we get Alexa to work on the Fire TV, which is Amazon's TV plug-in. You plug into your TV and you can watch stream video through there. So we've taken Alexa to new devices as well over the series, and we did that sort of slowly and carefully, always having a lot of testing in place to make sure that it was working. High bar on accuracy, so you had to be sure of not degrading the current performance of. You don't want to make the performance of your music playing worse by introducing shopping on the device. So there's all this balance between adding new features and keeping the accuracy of the current ones. So it was slow and steady and careful, and lots
I can only
of testing.
imagine you ask for Alexa to play you your favorite song, and it orders you a pair of pants instead.
Yep.
So those are things. And I mean, we had Curtis Northwood, I think is his last name, on here before, and he is the mind behind Clean Lab, and he worked with Alexa and the speech, and one of the things that his tool was trying to predict was how many times people would ask, "Hey Alexa," and it wouldn't respond. And he was talking about how difficult a problem that is, just because you don't know. Like, how are you supposed to know? Because Alexa's not going to tell you, "Oh, I heard Hey Alexa and I didn't respond," right?
Exactly.
So I imagine there's all kinds of crazy challenges like that. And I think before we dive into some of the other challenges that you faced around like these pipelines and these models, it would probably be good for myself and Adam too, I imagine, to know about what exactly is behind a virtual voice assistant. Like, what does that entail? What does that even look like? I don't even know.
Yeah, so there are several voice assistants in the world. So Alexa's one of them. You mentioned Siri, and other companies have their own versions. There are some small sort of custom business-to-business assistants out there, but I think they will have a lot of similarities between them. So you're talking about something that you talk to with your voice, and you ask it a question or ask it to do something, and it will come back and respond to you or do that thing in a short period of time. So we have a pipeline of different machine learning models under the hood, which make this happen. So the first thing in there is the speech recognition. So that's going to listen to your voice and transcribe the words that you've said, hopefully in a relatively accurate way so that it can pass it downstream. But this is obviously if it can make mistakes, and some of those mistakes might get passed downstream. And then we have to do some understanding the language. So there are many different ways that somebody can ask for something. So I could say, play me some music, or I could say, I want to listen to music. Two very different ways where the assistant should play some music. So we have to understand, which of the actions does the user want. So we have to analyze the language to classify it and decide which action should be taken. We also have to pick out any relevant keywords. So if I ask for what's the weather in Cambridge, I should get the weather in Cambridge, as opposed to if I ask what's the weather in London. So we need to know those important keywords that someone has asked about as well, so that we can, return the right result. then sometimes, the user doesn't give enough information in the first time, or you have to ask a question back to clarify. So there's some sort of a dialogue component in there as well. Often, some are more complicated than others. Dialogue is very hard, and so like trying to minimize the amount of dialogue is always a good idea at the moment. But there's often a dialogue which asks back, which city did you want the weather for, or who do you want to listen to? What sort of music would you like to listen to? And then some questions are more complicated than others. Playing music might be quite easy, but if I ask a factual question, maybe the system has to go out to Wikipedia and figure out what the answer is. That can be an entire machine learning model in itself, sort of question answering system. And then we have the final bit, which is the voice back, so the synthetic speech, which is going to speak the answer out to you. And synthetic speech is another machine learning model. So you've got speech recognition, sort of language understanding, dialogue, question answering, and synthetic speech. In this pipeline, 5 different machine learning models all chained together.
So I think this is rubbish, but I heard a rumor years ago that quite a large percentage, like over 10% of queries that went to it ended up with a bit of a mechanical Turk type backend where they didn't get understood. Is that nonsense?
It depends what you mean by mechanical Turk. Not all questions are answered by a machine learning component. Sometimes you do just want to be sure that the answer will be right, and so there are, as in I think most production systems involving language do have some canned answers. I would be very surprised if a voice assistant didn't at least have some sort of canned answers, or if there are popular questions that come up, there are people figuring out how to answer them. Because one of the things that happens in an assistant setting is events happen in the world and people ask about them, and you might not be prepared for them, you might not have the answers. So there can be world events that happen, or a celebrity dies and suddenly you have to have that information available to you, and you can't update your machine learning models quick enough. So most language systems I know are a hybrid, really. Even beyond virtual assistants, anything that involves sort of language understanding typically is a hybrid system of some rules and some machine learning there.
But no human in the background typing the answers that Alexa said.
So one of the things that a voice assistant does, I think all voice assistants try and answer very quickly, and so I don't think a person could answer quick enough, really. To satisfy fire.
The rumor I was told was that when Alexa doesn't understand you, that audio is sent directly to a call center, and then when you repeat it, you're connected to that person that gives you the answer, kind of thing. That's like they transcribe it or whatever. That was the kind of rumor, and I thought that kind of makes sense actually. But yeah, I thought.
But it couldn't be fast enough, right? That's the thing. I think, Catherin, you're saying is that.
But when it says "sorry, I didn't hear you," that buys it a little bit of time to go right. I don't know.
The human is frantically searching Wikipedia.
It's like, well, I think they said this. So, okay, it's different, quite a bit of a tangent. And you talked about other devices. So let's say it's Christmas dinner and the extended family are over, and like what a cousin starts the conversation about social media, listening to everything you say on your phone and sending adverts at you. What's your answer? How do you chip into that conversation as an expert?
So I do not think that social media websites are listening all the time. I think the processing power involved in listening and analyzing everybody's conversations is too much for very little value, like the actual value. But there have been studies people have done of internet traffic and in someone's house showing that actually this data is not being sent around the internet. I just don't see it being a valuable thing to do.
Yeah, no, I saw another thing about models that could do it without listening, actually, which was much more powerful. But yeah. Okay.
Yeah. So I'm wondering about this this pipeline of models that you're talking about and the speed that you're talking about. How are you able to get it to go through all of that at the rate that humans are able to have the patience for?
So usually I think the speech recognition part is the bit which is the slowest, and that takes most of the time when you're talking about interacting with a pipeline like this. So what most people will do is they will stream the audio into their speech recognizer as soon as a person starts talking. And so as you were talking, the speech recognition system is decoding what you were saying. And then by the time you have finished talking, very shortly after that, the result can be available, the transcription. If you don't do that, obviously you have to wait until someone's finished talking. And speech recognition systems, there's a trade-off between how long it takes and the accuracy. So you can make it run much faster than real time, but lose accuracy. So you want to play with as much time as you have. So that's why you start streaming up the audio as soon as the person talks. So you've got a little bit about real time, factor of 1, to be able to do the speech recognition. And then the rest of the steps are much quicker, I think. So you can, the language understanding can be very quick. You've built these big models offline. They can run very quickly. Potentially, going and looking things up in databases, if you have to look for answers, can take time. Sometimes the similar technology runs in call centers sometimes, where you are, maybe interacting with a big mainframe, and you call up your bank and say, "Can I have my bank balance?" And it's got to go and do a query to a database that's going to take a few seconds. They will play what they call ear cons, little sounds in your ear to tell you that, like the audio equivalent of the spinning cursor wheel. They'll play those in your ear to tell you that they're still listening to you and that they're doing something. So there are tricks like that which you can use. Most voice assistants don't use those. They really try and respond quickly, but in other scenarios, the back end just isn't responsive enough for that. So there's a lot of engineering, a lot of trying to architect these systems to be as fast as possible, and really have the trade-off between speed and accuracy at the right level, so that you get the best performance and the quickest time response.
So just interested to get your feel then. What are you kind of most excited about in the kind of space at the moment then? Like, what's on the horizon, research or even industry, things you've heard about? What kind of makes you think, that's going to be quite cool when it lands?
So I think there's a lot of so we know how to build, I think, a good speech recognition system. If you have data for the speech recognition system you want to build, you can usually build it. Getting that data might be tricky, but if you do, then you can.
Wait, can you explain that a little more? Like the data you need just from people talking to the speech recognition system, or you can't get that from like scouring news or just watching YouTube for a long time?
Well, you have to be obviously careful of the licenses of the data that you are using. So only some data is available for commercial use, or you have to pay to collect your own data. But we know how to take data of people speaking and build a fairly good, robust speech recognition system for a particular domain. So we might take people talking in the courts and build a legal transcription system, or people talking on the trading floor and build a financial speech recognition system. We can do those which work for specific scenarios. But there are lots of languages in the world where you don't have access to a lot of that data, and even collecting it would be hard. So there's a lot of work on what's called low resource speech recognition, low resource voice technology, where you're trying to build these systems for languages which just don't have the resources of English or Spanish or Mandarin or some of the big languages. And I think that's really interesting because, people, we learn with far less data than a speech recognition system needs right now. So there are some indications that we could train these things with less data than we currently need. So some of the biggest speech recognition systems are trained with, hundreds of thousands of hours of audio data, or even more than that. That's a lot of audio data. That's more than a lifetime's worth. And so obviously if a small child can learn to hear in a few years, that's far fewer hours than we're throwing at our speech recognition systems right now. So I think that's a really interesting field of research, and I'm looking forward to see where that goes. How can we build these systems with less data? And then I think another really interesting area, which is becoming much more feasible now that the underlying machine learning models across a lot of machine learning fields are becoming more standard, more similar to each other, there is much more scope for building these pipelines like a voice assistant, but other pipelines. Another one would be speech-to-speech translation. So you've got speech input, machine translation, and speech output. So it's another kind of pipeline you can build. You can imagine bringing computer vision into these things as well, and more language understanding. And there's a lot more combinations of things we could build. So I'm really looking forward to see where that goes in the future as well.
Ooh, yeah, that's cool to think about. And I know that my wife is from the Basque country, and Basque is one of those languages that doesn't have a lot of what you're talking about. Like, there's just not that many people that speak Basque in the world. There are not that many books that are written in Basque, et cetera, et cetera. Even though it is one of the oldest languages, it doesn't have the most data behind it. And so it's super cool to think about that with respect to these languages that potentially, like, if you fast forward 100 years, who knows if they're going to be around, right?
Yep.
I mean, 100 years is kind of everyone in the Basque country just threw something at the keyboard right now, or they turned off this podcast if they are listening because they think that I just said Basque is not going to be around in 100 years, which I'm not saying. I'm just saying that these languages, if you don't have strong adoption, they can dry up and die. And so
there are about
it's
6,500 languages in the world, I think, and many of them are dying out because they have very few speakers, and you need a community to keep them going. And there are some where governments of countries have invested in technology and in language learning to keep these languages alive, but others that don't have that investment, and they are just disappearing, which is a shame.
Yeah. And how... Yeah, that makes complete sense that the governments would want to continue this. Is that so? So do you foresee a future? This is just like going off on a big tangent, but like, would it be that people could learn or just have a practice partner? Like, if I want to learn Spanish, now I can use Duolingo, right? And it starts with the very simple sentences, but potentially maybe it's like I'm speaking to someone who is at a very native level, but it is just a computer.
Well, there are plenty of companies looking into this, and I don't know if you've heard of these large language models, which people are using as sort of conversational models now. So you can speak something and it will say something back that sort of makes sense. And the problem of dialogue becomes one of language modeling. And so that's an interesting approach. Those have some problems in that, the conversations out of those tend to, wander around a bit, and they're not really grounded in reality in the same way that you perhaps like them to be. But and they only exist for English and perhaps some other of the major languages. But I mean, there is certainly a potential in the future to have these conversational systems back and forth as a language learning method. I've heard of a few people really interested in this area, and you're right that learning a language is much better done with conversation, I think, than some of the other ways. You have to interact with people. We're social. Language is social, and learning it in isolation is hard. And so, being able to speak to a computer to learn is, possible, I think. Really,
it's ideal. Who knows if it is going to be needed, though, because the other piece that you said about speech-to-speech translation, or what was it?
Yeah, speech-to-speech translation, yes.
Yeah, that is something that I think about a lot with my neighbor who is in her 90s, and she only speaks German. And so whenever I talk to her, I get out my phone and have the phone listen, and then I read what it says, and then I kind of like try and talk to her back. Yeah, who knows where that will go, though?
Yeah, exactly. There's so many people where this could benefit. So many people who don't, even if technology can help with all of this. There are so many languages in the world that I think it can really help ease communication between a lot of people in different ways.
Just interested to hear then, like, asked about research and that, but have you seen out in the wild any like weird and wonderful applications that like sort of layman like me might not be familiar with, that we kind of wouldn't think of? Anything like that, like weird ways or interesting ways to use these kind of models to achieve a result?
I think a lot of the ways to use it wouldn't come as a surprise to you necessarily. So things like speech-to-speech translation, meeting transcription, which is something I've worked on in the past, which is always very popular. Can you transcribe a meeting and find the notes from it? But what I think is really interesting is, the way that people take these, somewhat generic pipelines and find specific niches to put them in. So, for example, you might have in the legal field, there are a lot of meetings, a lot of chats. It's very much driven by spoken word, and so there's a real niche there for voice technology to do something that you might not think is useful because you're not familiar with the legal world, and it wouldn't be useful in another place. Whereas, a voice assistant might be really great for, you have a factory that's a noisy factory floor and people have their hands busy operating machinery. And so a voice interaction is really useful there for a specific purpose. So I think taking these and finding the niches that they work in really well is more interesting than the ways that you put them together.
And actually, when you're saying that, it is so true how there are those note-taking apps. And I'm just trying to remember the name. I think it's like Adept that is working inside of the browser. So you tell it something like, I want all the financial reports for Q4. And it will go through your browser and it will give you that. And at least that's what it says, right? Like, who knows how it actually works? I have never tried it, so I cannot tell you how it is. But one thing that I think about with what you're talking about and then meeting transcriptions, and specifically when it comes to very, very niche things, like when I try and transcribe these podcasts, I always have a hard time because we talk about things that the understanding of the model, it doesn't get there from just if we use a regular model. And so I effectively have to go and train that model, or I have to keep telling it, no, I said MLOps. It means MLOps. That's how you should write it. But one thing that I'm wondering about in these like niche situations, if you have a meeting that is for a niche thing like your software design, and then you say, all right, we have these action items, and then it automatically transcribes the meeting, and then it gives you the action items, and it gives you a nice brief summary, and it gives you something that is very tangible that you can take away, that you didn't have to have someone there as the scribe the whole time.
Yeah, that's definitely something that is, really interesting, especially in some of these fields like the legal world, I think, where they have a lot of meetings. There are other fields as well, I'm sure, where they rely very heavily on, spoken meetings rather than written communication. And sometimes,
I think like politics,
these things can get lost to the myths of politics. I think it's often recorded as well and transcribed. So we have, the Hansard, the transcription of what goes on in Parliament here in the UK, published regularly, and the same in other courts. But yeah, you have to be careful not to lose these things, because it's really easy to have a meeting and feel like you've decided on things, and then come to review it later and realize that everybody's sort of forgotten what's gone on. So I think helping make people more efficient and log some of those action items, definitely something which is very valuable in some fields.
And then it automatically gives you a reminder 5 days afterwards and asks you how you're doing on that task.
Yeah, it would be nice if it did the task for me then.
Yeah, that's even better. I like that.
So if I say for like learners out there, people that want to get started in this space, what's like the Titanic data set for speech? Like, what's the first toy problem that people get started on?
There are a few problems. Trying to think if I can remember. So there's a data set called TIMIT, T-I-M-I-T, which is about phoneme recognition. So I don't know if you know what a phoneme is, but it's like a unit of sound. So words are made up of phonemes. So the word cat is k-at, 3 phonemes. And the word bat, b-at. So one problem in speech is, breaking words down into phonemes and recognizing those. So that's a relatively old data set though. But if you are very interested in just trying something out quickly, having a look at that, it might be a good place to look. But people often look at there's a data set called Switchboard, which is telephone conversations between pairs of people. I think these people were given topics to talk about. It's a very well-known data set. And if you have seen, a few years ago, there were some headlines, I think, out of Microsoft about how speech recognition had become superhuman and could do better than human performance. And that was based on results on this data set called Switchboard, where the system that Microsoft had was performing on a par or perhaps slightly better than what we expect the human transcription accuracy to be on that data set. So that's another which is very well known in the field. But speech recognition is actually one of the fields which has had a lot of shared data sets over the years. So even from when I started back in the early 2000s, there's shared data sets which were distributed around the world, and people figured out results on these, could compare results across research papers, worked in collaboration with other research institutes to find the best systems on. And those have stuck around, and there's a series of them over the years, sort of getting gradually harder and harder, starting from, something like reading newspaper speech all the way through to, meeting conversations and even harder than that, and then out into other languages. So there's plenty of data sets out there for speech recognition that are available, but probably the one that is most famous is Switchboard, but it is relatively smaller than some of the more recent data sets as well. Just which is a good place to get started on, but then it gives you the entry point to get into other data sets.
So I want to switch gears because you went out, you started Kingfisher Labs. What is the problem you're trying to tackle there?
I did. So Kingfisher Labs is a couple of years old now. And I founded this consultancy, which I started because I have been working with mostly startups now who are people who want to use this technology and need some expertise or some advice to get started. So work with a variety of different clients who do different things in the voice technology field.
Excellent. Okay, so now as you are looking ahead and looking forward, you're tackling some of these problems with the clients that you want to help get over this. You mentioned to us at the beginning, sometimes it's as easy as just starting with an off-the-shelf solution. Do you recommend that? Is that like what people pay you to? That you can't tell me that's what people pay you for.
No, that's not what people pay me for. A lot of companies do get started with the off-the-shelf solutions, and then once they've realized what their product could look like and they've got a little bit further on their thinking and they want to build the systems in-house because they're not quite right, the off-the-shelf ones, or they simply want to build up their own IP inside the company. They might have one or two machine learning people working with them already, and some of that expertise and real world knowledge from building these systems they're interested in, the technical side of building the systems, or else the management side, who to hire, how to interview them, how to organize their team effectively, and that side of things as well, and how to communicate between machine learning scientists and the business teams.
Nice. The translation layer is so important.
Yeah. Yes. So I work with the companies who've been through that stage of looking through the off-the-shelf solutions and figured out that that's not the path for them in the end, and they want to take it further than that.
Excellent. Are you hiring?
I personally am not hiring, but plenty of my clients are hiring machine learning scientists and machine learning, particularly MLOps. There is an awful need for this particular intersection of engineering and machine learning right now. So I know people hiring there.
Excellent. Awesome to hear. So if anyone would like to get a job or try and find out about that, can they reach out to you? I think you're in Slack. So, or is there a best way to connect with you?
So I'm on Twitter and LinkedIn.
There we
You
go.
can find me there. So on LinkedIn, it's Catherin Breslin, and on Twitter, my handle is Catherin BUK.
Excellent. Yeah, we'll leave the links to those in the description. This has been awesome, Catherin. Thank you so much for enlightening us on these different the workings behind when I talk to my inanimate objects in the house.
Fantastic. And I hope you realise now just why we need all these MLOps practices and engineers to make this all work, because it's a very complicated system with a lot of complex engineering behind it.
Completely.